Hello and a very warm welcome to all of you. I, Sankalp Patil, on behalf of MBTEL, would like to thank all of you for attending our webinar on functional safety ISO 26262. Today we have with us Mr. Martin Heininger as our key speaker. Before beginning the webinar, I will like to take you all through the flow of the webinar. So the webinar will be in two parts. The first 45 minutes will be the main part of the webinar, wherein Mr. Heininger will discuss about the different aspects of 26262 for functional safety projects. The last 15 minutes will be a question and answer round, wherein you can type your questions through the question box and we'll come back to you with the response for that. In case if there are too many questions and we are not able to address all the queries, we'll give you an email ID wherein you can send your queries and we will come back to you with the response as soon as possible. Now, before starting the webinar, I will like to introduce our key speaker for today, Mr. Heininger. Mr. Martin Heininger has around 15 years of industry experience and has worked extensively as a lead and project consultant for functional safety projects. He has also conducted many functional safety seminars on different standards like IEC 61508, ISO 26262, and RTCA DO 178B. He has an extensive experience in consulting and assisting projects on verification related to functional safety. Now I will request Martin to join to take this forward. Martin?
Thank you very much, Sankalp. From my side, also a very warm welcome to everybody to this webinar. As introduced by Sankalp, today the webinar is about giving an introduction and short overview about the ISO 26262 to give you some ideas about if you are on starting a project in this area where maybe the 26262 applies. What are the first steps? What has to be done to start with? Then in the third part, I want to give you some impression about the determination of the ASIL level. So whether you have to develop against ASIL level A, B, C, or D, very critical or not so critical. The fourth part is about the life cycle work products. What has to be documented, or what have you to prove, to show to certification authorities or certification bodies? What is the outcome if a standard applies? In the fifth part, I take one table out of the 26262 to give you an impression how the standard deal with certain areas, just as an example. And the whole webinar is about giving you an overview. In 1 hour, it's not possible to go in all the details of the standard, but I hope you get a good impression when you have to start a project, or you want to start a project in this functional safety area. And it's also from my side very important, as my project experience tells me that there are sometimes a lot of people who fear to start in this area. You know, it's too difficult or too much to do. From my side, it's everything can be done. Fear is not a good guidance. So I want to show you ways, at least give you an idea how a way could be to start in this area. In the very last area, we have one slide about the MBTEL and HICON collaboration, which you can see later on. So now let us start about an overview. There are 2 slides about the 26262 overview. First, overall, I want to say that as maybe most of you know, or some of you know, the 26262 is an adaptation or is derived from the IEC 61508. The IEC 61508 is the mother of all functional safety standards, and the automotive car industry said we have to develop our own standard which fits better our industry needs, as it's also done by other industries like medicine or railway or any other. The aerospace is a little bit of an exception, but most of the other industries have derived their own standard, and it's also written in the 61508 that either 61508 applies or the industry has her own adoption of it. So in the car industry it's 26262, which complies to the needs specific to the road vehicles. So road vehicles, if you see point 3, are defined as serious production passenger cars, which is also a very important point, because up to now the 26262 applies only to serious production passenger cars up to 3,500 kilograms. There is planned that it will be extended, the use of the 26262, or where it's valid also for heavy cars or lorries or buses in the next few years. I think it's not finally decided, and they are still discussing about the ways how it will be adapted, but there seems to be no doubt that it will be also valid for this kind of cars on the streets. Then this point 2 I left out, safety-rated systems that include electrical and/or electronic systems. So it's about electrical and/or electronic systems. As this part is increasing in the cars, it's getting a more and more important topic. So it's not about mechanics or hydraulics or anything like that. It's about electrical or electronics in the car. The 26262 addresses possible hazards caused by malfunctions behavior of EE, so-called EE system, safety-rated systems, and their interactions. That's very important. So it's really focused on the functionality, on the what happens if the ECU does not behave like intended, or the EE system does not behave like intended. It does not apply, the last point, to hazards related to electrical shocks, fire, smoke, heat, radiation, toxicity, flammability, or anything like that. So to all the environmental stuff. This is not part of 26262. It's a very important part, but not part of 26262. 26262 really focus on the functionality and all the risks which could come out of this. It's also focusing on the safety side, yeah, not on the security side. It's also important, as you can think of even scenarios in future. If you have car-to-car communication or car-to-X communication in future, where then the topic security, so misuse, intentionally misuse by powerful organizations or people who know details about certain systems, how they can misuse. This is also not part of the 26262. This would be also a separate topic. So now I like to introduce this picture. This is part of the 26262, and I like it very much because it gives you a very good overview about the content of the standard. There are 10 parts actually in the 26262. The last one was just published, I think, few weeks or months, at least this year. More organization of the standard than in content. Safety management, and it's very important ways to be considered. But there is also definitely an organizational part which has to. We need to organize certain things. We need to, for example, it's necessary, or different people have to come in a project. All this kind of scenarios are handled in the chat. You have also to take care about the organizational areas. Second line, safety life cycle, the content of the project. You try to define what is what are the risks could come out of the system. This is connected to phase 3, because about whether you use language, but at least you need requirements, and you also need requirements of what you have to implement with your customer. Also, kind of in parallel, you're writing down your functional requirement. Number 6, part 6 of the standard is all about software views, architecture, design for hardware, design architecture. Also, the constraints are there. We have to also take care about the production area of a product. We have to take care about the functional safety, more on this system, hardware, and software parts. Part 8 is supporting processes. Important part about documentation, possibilities, adaptations, possible risk in it. The last point, there are in the very end of my message is, it's what kind of tool you have, and then the standard defined for this webinar is first steps, what to do, how to functional safety. To have a proof that you have thought, and the outcome of this hazard analysis and risk assessment could be that there is no hazard or risk, which oh, is this critical or is not critical, then so due to some technical problem, we went away, but we are now back, so we can continue. So yeah, we had the ASIL determination. So quality management, you see, for in a lot of cases, you don't need to consider the 2626 case even. So now about the life cycle work products coming out of the 2626 or which you have to produce or have to show to a certification body or to your customer. As you see in the right corner of the slides, I'm going now through the 9 or 8 parts where I should give you just an impression about the work products of each area. Part number 2 is the functional safety management, and there you see you have to produce some evidence of competence. You have the organizational specific rules and processes for functional safety to document or to show, to demonstrate, but not only by words. You have to do it in a written form. Evidence of quality management, so your own quality policy in the company. Normally, functional safety assessment plan, there is more about specific areas about functional safety, so there you have to consider about the chapter 2 of this 2626. Evidence of field monitoring is things which are in the field, products which are in the field. You monitoring how many failures to use, maybe use it for certain argumentations. Concept phase, the third part, number 3 of the standard. What is the outcome of this, or what has at a minimum come out of this? You have to think about, or important is to demonstrate or to show, this is normally easy, yeah? Is it the development of a new product, or is it a modification of an existing product? If you're talking about an existing product and you modify it only, then it's, of course, you have a lot of the artifacts already, or you may have developed the product before the 2626 was even applicable, and it's a very interesting point to be discussed with the authorities, with your customer, whether you have to do a complete, bring the whole product now on a 2626 level, or you can start with doing using the 2626 only for the changes you're doing now. In case you're doing a complete new product, yeah, you have to do it the whole life cycle. Hazard analysis, risk assessment is what we talked with the first steps. Safety goals, we talked before. Functional safety concept, as I said. And the verification is to show that you have done it, or to verify that this work exists, this artifact exists, and normally it's the good quality policy that you have a 4I principle, and you're just normal company standard-wide quality policy, so that somebody checks that this work products here are proper and consistent and correct. Therefore, this is in this area here meant with verification report rather than testing or something like this. So now we're about production, where I said, okay, this is not in the focus or really main focus of this webinar. I'm going quite quickly through it. As you see, safety-ready content of production plan, safety-ready content of production control plan, control measure report, assessment report for capabilities of the production process, interesting, important words, safety-ready content of the maintenance plan, repair instructions, that we ensure over the whole life cycle of the product. Life cycle means as long as it's in the field, yeah. So even if you repair it 5 times, we still does not we still ensure that the functional safety is considered and the system is functional safe. We do not introduce new failures. Safety-related content of the information made available to the user. Instructions regarding field observation, safety-related content of the instructions for decommissioning. Even decommissioning is a topic, is addressed in the 2626 too. Yeah, very short overview, but you see there's a lot of stuff there. Chapter 8, part 8, supporting processes. There are 5 main parts. A distributed development is addressed. The change management is addressed here. The tool qualification, the config management, the documentation process. I left out the verification as I had it before on the slide, but I don't want to duplicate information. The verification is part of the part 4, 5, and 6 from my side. There are some statements about verification in this part 8, but nothing which is really important for this webinar. So distributed development, supplier selection report, so that you can demonstrate that you have the right suppliers which have the capabilities to work in a functional safety project, development interface agreements, supplier project plans, safety assessment reports of your suppliers. Or if you develop in your own company, but you have it distributed over the world, globalized, so you, then you have to, this stuff also applies. Change management, yeah, here they talk about a change management plan even, but it's not meaning that this is, I just take this as an example. This does not mean that you have to write an individual change management plan. You may put it as part of the configuration management plan or any other plan you can think of, which is in your case maybe the better one. You don't need to do individual each, even if it's a written plan, but you don't need to do everywhere there's a plan to do your own document. Change requests, very important, so that you document your changes. They have some system where the change request is clearly identified, the impact is clearly identified. Next step, impact analysis, change request, plans, change report. So that's about change management. Then tool qualification. I said, okay, there's a tool qualification evaluation report and a tool qualification report. It's pretty easy. Just 2 statements. The important bit is that there are 2 kinds of tools possible. One, where the tool can introduce errors into your software, into your system, which is running in the car. So in software, the compiler is a very good example there. Or the tool can only miss to find a failure, so do not detect an error. This is of course a different quality. There's all the verification tools. And normally if we talk about tool qualification, we talk about tool qualification in the verification area. So, and there is the need, what you have to prove that the tool is properly working. This effort is not as high, not too difficult to reach. Yeah? You have to prove that the tool does what it is supposed to be doing. The other area is more critical, but it applies very seldom. We're not doing normally a compiler validation or things like this for different reasons. Config management, configuration management plan. So what is your configuration management system? What is all described in the management plan? Documentation, as I also said already, it's in big project it makes sense to make even a plan about the documentation management strategy or the plan and document the strategy there. Yeah, documentation guideline requirements or templates and things like this. If the project is smaller, of course, this is not so important. Then we are on number 9, part 9, update of the so work product ASIL and the safety-oriented analysis. Update or establishing of the corresponding documentation due to requirements, decomposition. That's what I meant with the ASIL tailoring. Yeah, so this is to be documented. ASIL of the dependent failures, safety analysis. I want to go over this a bit quickly as this is not in the real focus of this webinar. Here now, part 4 and part 5. Here's our well-known V model. On the left side, the development part. On the right side, the verification part. This is from system side. You see here in the box, the top box is in slide 16 now detailed, and the software part is on slide 17, the next 2 slides. Important is that I introduced, from my feeling, in a lot of cases we discuss about system requirements, software high-level, software low-level requirements, for example, or at least here requirements, and then the software implementation, and then the testing accordingly. From my side, it's very important the design and the architecture, because without architecture and design and the proper traceability, this blue lines means also traceability there. Yeah, in whichever way, it's not. I don't say it's easy, but it's needs some thoughts. And then it can be done in a quite proper way, but this is required. Otherwise, your requirements alone are not good enough. And a lot of projects miss the architecture. That's at least my experience. The design and the architecture. They straight go to code, write some requirements, but miss the architectural part. So slide 16 about the outcome. We're talking about the work products for system. So you need to have a project plan and a safety plan. You have a technical safety requirements report, so system requirements. Therefore, I put it in the V model that you can see we are talking about in the high level. We have the validation and integration testing. As we are on system level, we have, of course, have the integration. As we have the whole system integrated, we're doing, let's say, validation testing. At least we have to give an answer to all these items written down in this box here, and we have on the very left side here the system design and all the areas. And you see there is quite they require, for example, a hardware software interface specification and system design specification, technical safety concept, specification of requirements for production operation and decommissioning. There we are going a little bit again in the production area, but important is the first three here. Yeah, so architecture, requirements, and validation or verification on the right side. So then on the software area, you have software safety requirements. Here are the details. You have a software unit design. You have the embedded software here. This is just the source code. This is always to be delivered. This is, of course, no problem. This is your product. This is your functionality. The software architectural design. So I want to demonstrate there are kind of two levels from my point of view, at least in bigger projects, high level and the lower level architecture, or first architecture or first design and then a lower level decomposition. And you have the unit testing or pure software testing, and you have the hardware software integration testing with verification plan, with verification reports or the results, verification specification, so your specification of your test cases, and so on and so forth. Again, back to the V model, because the last part which is missing is the hardware. And again, I'm back to the V model that which shows also the system part here, because the second V model is or could be system requirements, hardware requirements, and then the hardware instead of the software we had before. And there we have hardware integration testing and on the hardware level, which is the details are given here. Hardware safety requirements, again, the requirements, the hardware design, design specification, safety analysis, design verification report, the hardware itself as an outcome of the product, clear, like the same as the software. Hardware integration testing. Hardware integration test report is a simple example saying in the standard. However, you also need hardware. You have to describe the test case. You have to do a test procedure. You have to have test results. And to be able to document and demonstrate this all, if some certification body wants to make sample reviews on it, means normally an effort. And to be able to make it, to still see the project, that you get a profit out of your project, you need to do it in a very effective way. Same for the software, but it's also valid here for the hardware. I hope that you get a bit of an impression that the standard requires, let's say, quite a lot, and now you need, it's very good to have somebody experienced who could guide you a little bit through this part. As I said here, I'll make the example for the hardware integration test report. Yeah, it's only a test report, but what is in a proper test? What is the content of a proper test report? Not too much, but not too less. This is the difficult part of it. So as a last part before we come to the discussion, I took one example now out of the 26.26.2 part 6, the software part, and these are the software unit implementation methods. So the 26.26.2 gives you an example, gives you examples. What are methods, or what you have to consider when you implement the software? And typically they do it in a lot of cases in this table form. Yeah, there is these tables. Then you have here, in this case, the methods on the left side, and then you have the different levels, criticality levels, ASIL A, B, C, D. And 26.26.2 handles it in plus, which is highly recommended as far as I remember. Plus is recommended, so that's the high level. There's strong recommendation. You should follow this. If you're not following this point here, if it's plus in the standard, then you normally need good arguments. But if you have good arguments, it's not an issue. But you need good argument to not following it. The recommended is then there you get more options to argue, saying no, that's in my project not really important, so therefore I'm not fulfilling it, or I'm not following it. And the 0 or the O, it's neither recommended nor said it's cannot be used. It's just the third level. So there is normally you're not using it. And for example, here see what points do we have? One entry and one exit point of a subprogram and the functions. So we are now in a very low level. Let's say we are on the software level, of course, implementation. So functional safety 26.26.2 suggests to say you should have only one entry point to your function, only one exit point to your function or subprogram, and through all ASIL levels. The next point, no dynamic objects or variables or else online test during their creation. Here you see there's a relaxation in the ASIL level A. It's only recommended, where it's highly recommended for ASIL level B, C, or D. The initialization of variable, and this is good programming style from my point of view, has to be in a functional safety project there. It should be in every project, I think you probably agree. No multiple use of variable names. Also here you see a bit relaxation as a level A. Other ones has to be there. Question is, how do you prove that you do not have multiple use of variable names? There you have to start thinking of, because there is, at least if you need some, want to have some certificate, or you have some certification body, or you have your customer auditing you, you have to provide confidence that you have followed it. So that's the important part of it, thinking about, okay, yeah, it's easy, we do not have it, but how do we prove that we have not used multiple use of variable names? Avoid global variables or else justify their usage. Here you get some freedom, justify your usage. So if you have a good argument, avoid global variables, in my experience, is very difficult, to not say impossible, or if we do it completely, then we get other problems. So we need a good argument, we need an argument, we need a strategy, we need an architecture which could demonstrate that yes, we have used global variables, however, it's completely under control, as we can demonstrate here and that, and we have verified the issues about global variables. Limited use of pointers. In embedded systems, a very interesting point. Yeah, what is limited use of pointers? There you see, there is getting now the experience in the project. Yeah, how do we sell this to the customer, to the certification body, that we have limited use? Because normally, yeah, you have quite a number of pointers in a lot of projects, in one more and other less. But to say what is limited, it's an argument. You need strategy and argument, and so on and so forth for the rest. And this is now same for testing. This is now for all the areas, the different areas. You have such kind of tables there. There is one column missing where you get a reference to chapters inside the standard, so that you get a bit more information. It's not only the tables. There are sometimes more information available around the tables or in some other parts. But I wanted to just in this webinar give one slide there about how does such a table look like, and how does it feel, what do I write in the standard, what is in the standard, in example of a software unit implementation methods, you have now some hopefully detailed example, and you're a feeling what this 26262 is about. So that's about it in this webinar from my side. The very last slide is about the collaboration and the services which NBTEL and HighCon provide. We both together provide ISO 26262 consultancy. So if you have questions, if you are working in a project, you need consultancy there, we are offering it. We are offering functional safety validation and verification, either doing the testing or the validation and the verification, or do the consulting about the right strategy. Same for tool qualification. And of course, we're also developing in the automotive industry, the strong area from NBTEL, software and hardware. So, and there's a very last one now, your questions, and hopefully my answers or our answers. So feel free to enter now a question in the chat box down there. I try to answer it verbally, and if I can't answer, we would come back to you later on. Yeah, thank you very much from my side, and feel free to come up with your queries, questions. So I try to answer now some. The first question is, are there any specific recommendations for real-time multitasking applications like data sharing mechanisms, deadlocks, etc.? Just this may be an interesting point. It is a general topic. There is not a specific recommendations what you have to do. The 26262 is more about the processes and ask questions, or you have to go through the points, and if you have this kind of project, you have to maybe answer certain questions. And there is, of course, sharing mechanisms. For example, if you have an application which is ASIL C and another one is ASIL A, then yeah, you may be using you share maybe, or you do not share maybe, yeah, the memory. You make a split in time and memory. Deadlocks, of course, is it possible to get a deadlock? But there is not an answer there, or it's not about a specific technique in the standard. Yeah, but you have to think about the topic. There's no doubt, and you have to give answers in the functional safety if your project applies to it. Next question? What is different between technical safety requirements and software hardware safety requirements? Technical safety requirements, these are the system requirements. In this area you don't care about is it implemented in hardware, is it in software. You make a black box around your system saying, so what functionality has to be implemented? Whether I implement the functionality in hardware or I implement it in software, we don't care. Or you don't care at this area. You just define about the system. And then from this downwards, you define then your hardware requirements, because you implement a certain part of a functionality or the whole functionality in hardware. Therefore, you now have around your hardware box your black box again. And what is your input to your hardware? What is your output? And you write the requirements in this way, and therefore you get then a hardware requirements. And the same for software. The functionality you implement in software, you have then the software requirements. But I agree, it's not easy, and especially if you have no experience with requirements and breaking down requirements from one level, make engineering, requirement engineering, it is very difficult to have a feeling for it. So there is some guidance for sure, a good way if you have to start one first. Next question, assuming all this is followed in our project, what is the procedure for certification? There is your, this is now very difficult. This depends on your project specific areas. There are, let's say, two scenarios from my point of view. One, your customer is explicitly expecting you to develop your system against ASIL C, for example. Then you probably have to provide everything to your customer, and your customer probably know what are the next steps toward a certification or to get a certificate. But you may also develop a system or ECU or something, or a real-time operating system or whatever, let's say just a part of a software, where you for advertisement reasons or for just to separate from your competitors in the market, you want to have a certification that your system fulfills ASIL A, B, C, or D. Then you can go to any certification body in Germany, at least in Germany, in Europe. There is the organization TÜV, a well-known one, DEKRA, SGS, it's more in France. So there are certain worldwide active, in America and Asia there are probably different ones, authorized organizations which are allowed to provide you a third-party opinion and give you a certificate about your system, saying, okay, yes, your project has fulfilled the whatever required 26262 requirements. So this gives some value to your product. And this is the second part. So one is your customer is guiding you, and the second one is from yourself. You're looking for a certification body, and you try to get from him a certificate. As he audits it then, and you have a third-party opinion, and you get hopefully a successful audit, and then you get a stamp. And you have, of course, choose somebody who is well known so that your customers know, he got it from this organization, and it's very good. Next question, what is the PFD for each ASIL? I want to go over this, but we come back on this, as for me it's not 100% clear what is meant by PFD at the moment. Can you please mention ASIL levels for hardware implementation just as you did for software implementation? There is some misunderstanding here, I think. The ASIL level does not apply to, if you, in a normal case, you have a ECU, you have a embedded system, software and hardware together, and your ASIL level applies to both. It's even worse, it applies to the car in the end. The whole system, what is a system again, but the whole system has to fulfill an ASIL level. And there is this part number 9 where you have decomposition, where you can, strategies about, of course, the car, you can't develop everything in the car against ASIL level D. Of course, you have parts which are ASIL level D. And you are allowed, if you have a certain design in your car, to decompose and say, okay, this system is ASIL D, this system is ASIL C, this is ASIL A, ASIL B. And this is also possible on smaller ECUs or on smaller parts of your system, again, where you can maybe decompose. But there is not a hardware ASIL level or a software ASIL level. There is a system ASIL level. That's the message here. For more details, we would need a longer time to speak about it. It's a very good question and very important topic. Our product counts as a safety implement out of context. Okay, this question is too specific. I hope I have answered at least a little bit. Please come back, or we will try to come back to you on this question later on. But don't hesitate to send a question. I just continue here with a slide where you have then an email address, e.seminar@embitel.com. If you write your question to that email address, we definitely will come back to you and give you an answer. how far should we go with software tool qualification? Is it necessary to qualify our document management system? No, for sure not. That is exactly what I meant with the tool qualification. A very good question, and it comes very often for people who start in this. No, nobody requires to qualify MS Word or whatever Microsoft tool, or even a DOORS database, or a requirement management tool, a professional management tool. Your requirements, DOORS for example, nobody requests you to certify this. This is easy to answer, but the question is does this really answer your question? Because you may have other tools. What to do about your compiler, for example, is an interesting question. How far to go with your compiler certification? As I said, there is no compiler certification. Nobody requests you to really certify your compiler. But yes, you have to do something. You have to show some confidence that your compiler does not have failures, that your compiler works properly. As I have most of my experience, or 10 years of the 15 experience, is mostly aerospace. In the aerospace, as you may know, or as you may think of, they use just very old stuff like the compiler, compiler versions which are 2, 3, 4, 5 years old. Yeah, all the failures are known by just the market. The market used it, and therefore a lot of failure lists exists, and therefore we know what is working on a compiler, we know what is not working, and therefore we choose this compiler. So take the late, this is an extreme case, yeah. Also it's used in the aerospace, but probably not working for the car industry. But in the car industry, using the latest compiler just from yesterday, let's say, yeah, some compiler new version because it solves some technical issue you have, is also not a wise idea. Because there you have, of course, you can't say the failures are known as it is out of yesterday. You're the first user of it. So in these two extreme cases, you have to, from my point of view, you have to find a middle way and an argumentation. And it's, from my point of view, a good idea to use such a thing, either use a consultant or use your certification buddy. Ask the right question, because normally you not say yes or no until you certify the whole project. This is the nature of a certification body. However, if you raise the question the right way, you can get the answer what you need. So is he happy with this compiler version and what you're doing to certify your compiler, or let's say to validate your compiler, or is he not happy? Because to test the compiler really completely is, I think everybody agrees, impossible. From a money point of view, makes no sense. So I have answered now the questions, actually, what I have got here. Most of them, there is one or two. The PFD is for me not clear for the moment, but I will have a look on it. What is the PFD of each ASIL? And there is one more question where I'm not 100% certain about it, where we would like to come back to you. But as we are now just at the end, and if there is no more question from my point of view, I would like to give back the ball to Embitel. Maybe Mr. Sankalp, you would like to finish off the WebEx, a webinar? If not so, I would close the webinar from my side. Want to thank you very much. Thank you for the very good questions. As I said, there are some questions there which are just good, yeah, and show that you have understood the topic, that you know what you're talking about. So I'm very glad and happy on that. And once again, don't hesitate to contact either Embitel or HighCon on this email address here to discuss more about your specific projects and issues, if there are one. Thank you very much, and goodbye.